Hello, Chris Keyack here with Keyack Technology Solutions. In this video today, I'm going to try to talk about a concept I've been brainstorming. I'm just, going through sort of a daily training series for myself of how to leverage language learning models and generative AI and just come up with new ideas and new ways to potentially connect the dots and figure out how to use this technology for different things. And in this video, I'm actually going to show that I was trying to see if I could figure out how to read existing Tekla Structures models and describe them in some sort of generic way. And so I've got three files here. I've got a JSON file, an XML file, and a C# file. And I was trying to find some sort of language or text-based way to describe the contents and even maybe the relationship of the objects of this Tekla Structures model, and see if I can automatically generate reports, find trends, and just use human queries against, like human language, English language queries against the data and the objects found in those files. And even more intently, I wanted to, I chose C# because there are so many programming like AI type things out there. And then also I was trying to say, could I take an actual model, generate, so I have an automated C# code generator that will read the objects in the model and automatically create C# code like in the API. So watch, if I actually open this up, you'll see that this is actually that code. Like I have a tool that reads the objects in the model and automatically generates the C# code with the Tekla API. Now, why would I do something like that? Well, where I was going with this is I was trying to see if I could actually sort of like scan boatloads of models and then also tell it to sort of look at code that I've written before, because I've got a massive code library of stuff I've just done, forever. And I was just trying to see if I could get it to maybe start to look at patterns of how I've written plugins or API tools, which have logic and variables and things in them, and how I've sort of structured those. So I have organized code. Then I have a generic way of lots and lots and lots and lots of examples of, Tekla Structures objects and things based on my code generators and scanning models. And then I was trying to see if I could almost somewhat give a narrative that connects those two pieces together. Now, I don't know, I'm just thinking through yet. I haven't really tested that fully yet, but I just want to show you kind of like where did I go with just doing simple queries and reports against the model. So I got these three files. I just want you to see what's going on, right? So this is a C# representation of the model using the Tekla Structures API. So every instance of every individual beam object and column object are actually described in here. In the XML file, this is actually just an assembly parts dump. It's a bill of material dump. Now, one difference here when I actually kind of test this that's different is that this has a quantity. It doesn't have every instance in it. It takes the piece mark and then gives a quantity. And you're going to see how I query that here when I do a test. And then I also have a JSON file. Now, the reason why I chose JSON or XML is that these are probably the two most common generic ways that are ASCII format, like text-based format for web service data. And it's such an easy, human-readable language way to describe objects in a very I would say generic way or cross-platform way, whereas C# is very programming language specific. And the reason why I did the programming language was, again, I was just trying to see if I could make a relationship between code I've written versus scanning boatloads and tons of models, and see if it could start to automatically generate relationships based on English prompts that say scan the model, look at my code, and try to make relationships to that. And then I'm just trying to see if I could say, could I start to automate tool queries or creation based on scan my Tekla model, look at code and methods and functions and things that I've written, and see if you can help me sort of do on the fly type of functions and queries for that job. There are so many times where I've done tools that are job specific, right? I got these big ass jobs and I'm just trying to do, I need something whipped up really quick to do just this thing or scanning or this fixer on the model, right? And so, I maybe spend 2-3 hours writing that. I've got tons of templates of that type of stuff that I've written and done before, and then I tweak them. But if I could just kind of human language that and then scan all those cool little methods and library of tools and things I've done, and then make a connection between the data and the model, and then actually tools I've written, and it sees relationships between the C# code. I just was wondering if I've got something there. And then if there was actually all of the macro commands because you can actually record commands in Tekla with the API, kind of like how you can record commands in Excel, and you can make macros. So if you could actually scan the API objects, describe them in C#, look at historical code of things that you've written, and then there was an actual library of commands in Tekla that were somehow described like in macro language in C#, and there was a way to actually parse relationships between all three of those together, man, that would be something else. Like that would be incredible. And then I even thought one more thing, and sorry, I'm just kind of talking out loud here, but I thought one more thing where I've seen people actually draw sketches of stuff, right? And there's image recognition. So you can actually draw sketches of things, like pictures of things. And then if you describe those, and there's the text recognition for the labels of those objects, and you can describe them well enough and what's going on in that picture, then you could actually say, scan stuff in the actual model, look at my picture, listen to my language that I'm telling you of what I'm trying to do, look at my code libraries, and try to make relationships and bring all that stuff together. Now, that may seem a bit pie in the sky, and it probably is a little bit pie in the sky right now, but I want you to really watch my video a couple of times here and listen to what I'm saying, right? If you can get that system and agents kind of set up to trained on those very specific inputs and processes, and then finding relationships of those and like teaching it how to connect those things together and call code and things that you've done before to make on the fly tools, based on that library, and then querying like the actual models, looking at sketches that you're just quickly whipping up together, something like that. I don't know, just there's a lot of potential and opportunity. Again, might be pie in the sky, kind of dreaming here, but I'm just trying to learn and figure out, based on my 25 years of experience in working with programming tools and steel detailing and BIM models, how can I start to creatively connect all that knowledge together to help expedite just creating things that I need on the fly to make me more productive without where the ROI is worth it, right? If I can tell it like, hey, I just need this really quick job specific tool, can you help me whip something up, and I can depend on it, right? And not everybody's going to have this, because I've got my 25 years of just doing stuff, and I know how that I'm also querying and looking up against here. But I'm just saying that if I have that, that's extremely powerful to make it worthwhile, where like, oh man, I just need this quick tool, rather than sitting there trying to scan through and manually do that work, or trying to even code it and spend the 2 or 3 hours to do that. Could I just say something in like a few minutes, and then maybe tweak it a little bit here and there, and boom, I've got that thing fixed and I'm doing something in the model. I don't know, just trying to think of where my mind could go with this. So I'm going to go ahead and just minimize this and close this down. And so let's open up GPT here. And so I'll just start a new conversation. And I'm gonna start by just dumping in maybe the let's see. I'll just go right here and I'll dump the JSON file, right? So that's nice and easy. So I'm just going to say, read through and tell me all the objects that have, and actually I'm going to get very specific because I have assemblies and parts described in there. So I'm going to say, tell me all the part objects in this file that have the have a name of beam. Let's just see what it gives me. Oh, cool. So, okay, so it's actually, it actually gave me the list. I wanted just the quantity, but it actually went through and it found all of the objects that have that and listed the properties. So, hey, that's pretty cool. So what do I actually want here? Let me just maximize that. I just want to know how many part objects in the JSON file have the name beam. Let's just see what it says. Okay, so it says 6 part objects with the name beam. Now I know that's not correct because I've actually got 40. So watch, if I go into Tekla, right, I'm gonna come in here and down here at the bottom and I search for beam and hit enter, it tells me that there's a quantity of 40. So I know that there's 40 actual instances of quantity in the model. So what I'm gonna do is I'm gonna say, let me go back to GPT here. I'm gonna actually say, you know what? I messed you up. I only described one instance of each object, and I'll even just be specific, each part object, and then incremented the other similar instances with the quantity property. Can you look at all of the part objects on all of the assemblies and tell me how many total parts have the name beam. Let's see if that fixed it up. Oh man, there it is. And this is actually more descriptive. This is the second time I did this, and of course I can't remember how I exactly wrote it like the first time, but I got to the same end result. And actually I did it a little bit trashier, like how I kind of wrote like the prompt here to fix it and tell it what I was doing. But it actually gave me a lot more descriptive data, and it told me the marks. It understood the logic like of what I was doing. So this is what I'm trying to like just explain here. Like, yes, hey, it's just predictive language. Like, and when you actually start to study more how like language learning models work and how all of this is actually working behind the scenes, the more you can start to understand kind of how you can connect some of these things together and make sure that you're doing good prompts to get what you're looking for. So I'm still a domain expert. I have to use my Tekla lingo or maybe programming lingo to scan things and do stuff, but this is pretty amazing. So, I just wanted you to see that, like, I could even take this to the next level. I could say export, create a Excel spreadsheet of all the parts that are of all the parts sorted by the profile property and group the parts that have the same profile name or profile description. I guess I'll just say profile. We'll just do that. Let's see if it does that. Okay, so here it just returned. So I'm going to see, like, I again feel like I didn't do that description very well, but sometimes that actually shows you like, are you going to get the results that you want? So I exported that out. I'm just going to fire this bad boy up and then let's see what I get. That's pretty cool, actually. So it reads the beam objects and it counted them up based off of that profile. Okay, well, it looks like, oh, that's interesting. It really sorted the objects based off the different piece mark as well. So it read all the properties, and then it just kind of basically gave me an Excel spreadsheet of that, I guess really of the JSON file. So I could have, and did it sort it right though? Yes, it did. It did sort by profile. So you can see that the lower, smaller profiles are sorted to bigger. Now look at this. This is awesome. Of course I could use the Tekla template editor and I could generate a report and I could get this, right? I mean, that's cool. I can get this, but are you seeing where I'm going with this? If Tekla starts to embed like human language queryable like voice command prompts or typable prompts rather than, and maybe it's using the template editor under the hood to query the core or the database, or if there's just some sort of generic queryable way to fetch the data in JSON, XML, or in C# or whatever, and you just have quick access to caching that data, and then you have LLM queries just pinging against that. There's no need to, have to learn the template editor, to generate reports and then just dump it out to Excel. So it's like linking all these different technologies and things together to just make things just way easier. And, getting a quick, simple Excel spreadsheet report is something that people want all of the time out of Tekla. So I just wanted to kind of showcase, like, I'm probably a little bit all over the place in the video, and this is not a super duper professional video. This is more like a discovery and kind of learning and sharing knowledge video. But hopefully you got some really neat ideas coming from what you saw here. Okay, so I want to just try to take this to one other step and level here. I'm just going to say, read the JSON file and tell me with some analytics, or I don't know, for lack of a better word, tell me, well, let's just keep it simple, right? So tell me some trends about the objects that you see in the file and their properties. I don't know, like, I don't really know what I want here. I'm just trying to be very generic and see what the heck this thing does. Okay, so it's kind of telling me the properties. It's kind of cool, right? So it's saying the majority of the assemblies and parts are categorized as columns or beams. That's true. That's right. It's telling me kind of like what properties are on the objects. It's kind of actually giving me commonality between like what it sees for a lot of the profiles and then the material grade. Like all parts use the same material grade. This is kind of, so look, I mean, this is kind of cool. It's actually showing me that, hey, there's a lot of similarity between the length, and a lot of them are the same length, and there's grouping by profiles. So like, I know I may be like overreacting because I'm overthinking ahead of like what's possible with this. But if you just were doing, if you were trying to discover stuff, like sometimes you don't know what you're searching for. That's kind of what's really awesome about big data, is sometimes you got lots of stuff and you don't really know what kind of trends and things you're looking for. But hear me out. If you had gobs and gobs and gobs of models and designs that you were doing, and you started to just do human readable queries, like, or just normal language queries, like you were trying to read designs and you were trying to see how much of your firm's designs were optimized for mass, or building weights based on different categorization. You're making dynamic queries without having to write, hardcore SQL queries or any kind of stuff like that. And, even if you connect this to like pricing data, historical accounting data, like cost data, of labor data, of things that you're doing. I'm just saying there's just so much information that you can query and trends and get analysis. And then I think I've even seen it, man, where you like can take some of these things and then just tell it to automatically make charts and stuff for you, right? And like pump that out to Excel or PowerPoint. So I mean, I'm just again, I'm in learning mode, just trying to figure this out. And I'm even using old ChatGPT 4 here versus like the newer models and stuff like that. But pretty insightful stuff. If you can imagine it, it might not be all there today, but if you can start to imagine it and you start to think of all those little things that you do and you start connecting the dots, right? That's what I am. I'm a connect the dots guy. I see all these little things. I see how data connects together. And if you start imagining that stuff and then get kind of a little bit creative and understanding more how the system works, you might be able to do things that took you a lot of time before and kind of take them to the next level.